Scary sounds from space. This is what the collision of two black holes sounds like. This is what Earth sounds like from outer space. This is what lightning on Jupiter sounds like. This is what the star KIC 76711081b sounds like.
Blue, purple, and pink. Alright, so anyways, I'm going to start off with my outline. Alright, then I'm going to do blue, purple, and pink. Alright, then this time I'm going to get a plastic bag instead of the magazine paper. Alright, then I'm just going to like dab it a few times, lay it down, give it a few punches. Okay, then you're going to give it a black shadow. And then put your bowl on it right there. And then cover it in black. Grab the pink and give it some of that. Same thing with the purple. And then give it some stars. And review. Oh, that's another spicy meatball!
If there is one thing that you do this week, make sure it's going outside on April 20th to see an extremely rare solar eclipse that will only happen 7 times this century. We are about to witness a hybrid solar eclipse this week, and if you're in the right location, you will get to see the famous Ring of Fire. It will be visible across most of Australia, Asia, and the Pacific, while those of you in the US will have to miss out this time. We are watching the moon pass between the Earth and the Sun, casting its massive shadow on the Earth in the process. For details on how to view it where you are, just look up April 20th eclipse and your location. It should be somewhere in the early afternoon on April 20th. I'm serious, don't miss this one. Seen this viral video showing exactly what would happen if a needle hit the Earth at the speed of light, and I wanted to see just how realistic this is, so I did the math. So let's assume the needle is made of just iron and weighs 1 gram and is traveling at 99.9999% the speed of light. When it strikes the Earth, it will have a kinetic energy of 201 million billion joules of energy. That is the equivalent of 3 Tsar bombs, the largest nuclear weapon ever detonated. It would definitely create an impact crater, significantly smaller than if it were an asteroid because the needle is just much smaller, but definitely big enough to cause some damage. It would form a huge fireball, probably a bit smaller than this, but still much bigger than even the biggest nukes. Now, of course, this is highly theoretical and nothing can travel at the speed of light, so you don't have to worry. You need to stop whatever you're doing because we have breaking astrophysics news. Just a few years ago, the Event Horizon Telescope team took this image of the black hole at the center of the galaxy M87. However, only a few minutes ago, that same Event Horizon Telescope team has announced that they've taken a photo of the supermassive black hole at the center of our very own Milky Way galaxy, Sagittarius A star. Take a look.
And we're going to zoom in to Sagittarius, the Archer, which is high in the sky above northern Chile. And we will go and zoom in first in the optical, but we have to switch to the infrared because there we can penetrate all the way into the galaxy. We leave tens of millions of stars behind and we get to the place where stars are in orbit around a dark spot. And when we switch then to our radio eyes and we use a network of telescopes to resolve further and further, I can present to you the image of Sagittarius star, the black hole at the galactic center.